Alright. Mentally math!
Let's get mental!
That was pretty good. Alrighty. So, you get started, get out ahead of me. Today's lesson is pretty short. There's only one actual example.
What?
Yeah, I know. I sort of had to come on. I mean, they sort of had an introductory example in the book, so I took that, and then there's.
Wait, there's only one example?
Yeah, it's really short and it's pretty reviewy, but it is important. It is taking something, a tool that we're going to continue to use, doing it with really simple problems that we could do with mental math, to be honest, but that's a good way of just kind of learning the method. So
Example 1, then written practice.
yeah. So today you have plenty of time to do all the written practice. Yay!
Wait, we get to do all the written practice?
Yes.
Let's go.
Alrighty. So I guess people have had a chance to get a couple ahead of me or so.
Yeah.
Okay. So 8 times $1.25 is going to be $10. See, maybe my zero. How cool it is! I totally did that on purpose. Super edgy. Yes. All right, and then multiplying this by 10 is 1 boingy. So that'll be 127 and 5/10. Then for this one, subtract 5 from the 70, then 75, then you got 70, and divide that by 2. Get 35. Converting things in the metric system. Oh, so simple. So in this case, there are 10 millimeters for every centimeter, and so it's 350 millimeters. Well, that of course gets quite a bit more complicated.
It's not mental math. Wait, I can't.
What?
I mean, for G.
For G.
It's kind of covered.
Of. The word that's cut off is of. Okay. Types of meat. So how many different meals can you make with 2 types of meat, 4 types of vegetables, and 2 types of bread? I know, right? Okay, so exponent is just 1/2 times 1/2 is 1/4. And then 1/5 of 45 is 9, so 9 times 3 is 27. And then these seem much more complicated than they really are. It's just take your numbers and just plug it into multiplication. So 2 times 4 times 2 is really all there is to that. It was 2, right? Yeah. So 16 different combinations. You just have to multiply everything.
Mr. Petrie?
Yeah.
So the method you showed us yesterday is for if it gives you like a few numbers. And then this method is for like if it gives you like a certain amount of each, and I don't know really how to explain this.
Right. Like different types of items. So are you guys talking about math?
Yeah.
Okay. What's the question here?
Oh, I'm helping with numbers with age.
Oh, okay. All right. Okay. Well, you can try to do it and just check yourself with me. Yeah, it's the same. It's the same sort of thing. Of this is matching different types of items with each other. In which case, you still just multiply all the numbers, and the other it's kind of a different type of formula of how many sequences of numbers can you make with one set of numbers. Okay, so 10 times 6 is 60, plus 4 is 64. Square root is 8 times 3 is 24. double that number is 48 plus 1, 49, square root 7 times 8, 56, a little busy, minus 1, 55 divided by 5 is 11, then square that number is 121. Yes? What was the question? For G, oh, nope. I believe with things like this, with types, you just plug the numbers in and multiply them. The other, what you're thinking of is for a sequence of numbers. How many combinations of numbers can you get with a sequence of numbers? This is different. It's you've got different types of things to mix and match. What are the total number of combinations you could have? They're a little bit different. I mean, similar, but different. Okay, so ratio word problem. So we're going to talk about ratio boxes, and yes, I know you could do this with mental math. However, we are kind of showing a method here that we will apply to more difficult problems. So with this question, the ratio of parrots to macaws at a bird sanctuary was 3 to 5. If there were 45 parrots, how many how many macaws were there? So we're showing how to solve things with ratio boxes. And so for a ratio box, you have, well, one column for your ratios, and then the other for your actual count. I'm so edgy today. And so now I know you could probably look at this and go, oh, hey, it's 3 times 15, so I probably just need to multiply 5 times 15, right? But we are doing the cross multiplicative goodness to try to solve these, or at least showing you how to set it up. So essentially, I'm afraid to try to do this right now. Oh, great. Thanks for nothing. So we're going to multiply those. And we're going to multiply those. Yes, and make an algebraic equation. Yes. So doing the cross multiplicativeness, 3 times m equals 5 times 45. I'm actually going to do it the other way around for reasons.
But can I just set this up in a test? Would you?
Okay, great. So if you're wondering, do you have to do it this way for a test? If they say on the test, use ratio boxes to solve this problem, then yes, they are checking to see if you know the Saxon method for doing this that was taught to you. And that's what the test question is covering. If they just say, like, without saying anything else, the ratio of parrots and macaws at the bird sanctuary is 3 to 5, there were 45 parrots, how many macaws were there? As far as I'm concerned, if they do not give specific instructions, you can solve it any way you want. Okay. But if they say use ratio box, then you need to show the method that we're learning today. So and you know, when we're thinking about these, yeah, you just got to think that these are equivalent, that they will have to work out to be equivalent, kind of like equivalent fractions. So we can just figure that out. So then you can get to 3 equals 225, and then divide each one. You can set up a division problem. And lo and behold, the answer is the answer 75?
Yes. No,
75 macaws! No snakes in this one. Sorry, buddy. Yeah, 75 macaws. Please do not forget your nouns.
Grammar and meaning.
Okay. So, you try to solve this using your own ratio boxes. What? What's up? I fished one out of, it was sort of an introductory.
That was the new concept.
Yeah, that was under the new concepts, but I seriously wanted a little bit more for us to work with. Right. So this time, and plus that shows what we're doing. So this time, solve this problem the same way I just solved that using so draw a ratio box for this. Do the cross multiplicative goodness. So in the auditorium, the ratio of boys to girls was 5-4. If there were 200 girls in the auditorium, how many boys were there? So I'm going to, could your knees please face the front? So yeah, make a ratio box. Got one column for your ratio, one column for the actual number. Plug in all the information that you have. Figure out what you don't have. Set up some cross multiplicative goodness. Solve your algebraic equation. Even though you can probably do this with mental math. But it's a simple problem so that it's really a matter of just walking through the method rather than being particularly flabbergasted by it being some really hard math problem. Okay, so that should have given you plenty of time. Set up a ratio box. Excuse me? Oh, sure. I'm gonna say X.
I just chose B because they're boys.
Says for boys. Okay, I can do that. Sure. I'll do B. So 1 is your ratio, 1 is your actual count, or the actual numbers. And then
I didn't write the ratio after.
try to make a habit of doing that because it makes it clear. And then they say boys to girls here, so I will set up my problem like that. B and G, 5-4. They give the actual count as 200, and then we'll make that B for boy. Then cross multiplicative goodness. We'll take those. And okay, I will do mental math for this because I think we can all agree that 5 times 200 is 1,000.
I don't agree.
Alright, and then dividing each part by 4 gets us B equals 250 boys. Okay. And that's today's lesson. Hey, we're having a chill week. It's cool.